Alright, and here's our last problem. Story problem. You are riding in a taxi. The company charges $10 to get a ride, plus 25 cents for each mile traveled. Okay, part A says, write a function to represent the cost of riding in the taxi. Let C represent the total cost, and M represent each mile driven. Okay, now, again, I like you to circle the things that you know, the important stuff. Okay, it's not really important that we're riding in a taxi, it doesn't tell us much, but it is important that the company charges $10 just to get a ride. Okay, as soon as I hop in that taxi, I've got to pay $10. Okay, plus 25 cents for each mile traveled. Alright, so that's what we know. Okay, then down here in part A, it says we're trying to represent the cost of riding the taxi, so that's what we're trying to find out. Okay, is the total cost of riding the taxi. Alright, so first thing I want you to do is write a verbal model. Okay, tell me how these things go together. Okay, well, we know we've got to represent the total cost. Okay, and I guess I should put total here. Okay, so the total cost, that's equal to, well, what do we have to pay for? Well, we've got to pay some money just to get in the car, okay, to get a ride. Alright, so I'm going to call that the initial fee. You could call that something else, whatever makes sense to you. Okay, initial means starting, so the starting fee is what I have to pay no matter what. Then we also have to pay some money for each mile, so plus the cost for each, or sorry, let's try that again. Plus we have to pay the cost for how many miles we drive. Okay? Sorry about the horrible handwriting here, but this iPad just isn't working well for me right now, but we'll make do with it. Okay, so we got our total cost equals our initial fee, the amount we have to pay to start with, plus the cost of the miles we drive. Alright? Well, it says we're going to let C represent the total cost. Our initial fee, we know that. They gave that to us. It's $10. Plus, now we need a way to represent the cost of the miles we drive using the variable M. Well, I can't just put M, because then that would be like I would add $1 for each mile I drive. Okay? So it's 25 cents for each mile. So it's 25 cents times each mile I drive. Okay, so here's my function right here. The total cost of the ride equals $10 plus 25 cents times each mile I drive. Okay? Well, now we got to make ourselves an input-output table. So I'm going to make myself an X. Actually, here, let's make this over this way farther. Okay? I'm going to make myself an X. I'm going to make myself my function, C equals 10 plus 0.25m. And I'm going to need, actually, sorry, I should back this up here. Give me just a second. Our x value is not going to be x this time. Okay, now let's stop and think about why that is. Okay, because our x value needs to be our input. Okay, so that should be m. Okay, I'm just going to write over with m. Then our output is our total cost, our C. Okay, so when I put in a number for each mile driven, that's going to change the total cost. Alright, well, it says showing the cost of riding 10, 20, and 30 miles, so those are my inputs, 10, 20, 30. Okay, now I plug them into my function, C equals 10 plus 0.25 times 10. Alright, so we need to figure out the multiplication first. 0.25 times 10. Well, that is $2.50. Okay, plus my 10, that gives me $12.50 here. Alright, then we plug in the next one. C equals 10 plus 0.25 times 20. Okay, well, 0.25 times 20, that is $5. Okay, plus my 10 is 15. Now, on one like that, I would probably expect you to show your work, okay, just for the sake of time. I'm doing it in my head right now, but you should probably show me somewhere over here, 0.25 times 20, okay, and solve that out and show it. Now, C equals 10 plus 0.25 times 30. Okay, 0.25 times 30, that is $7.50, plus 10, that's $17.50. Okay? So here's my input-output table that I've got. And I'll go ahead and erase this work up here for you. Okay, there's my input-output table. Now it also says then graph the function. So over here, we need to make a graph. Okay, now we need to know how to correctly label a graph. Okay, our x values, our inputs, or in this case our m, are always going to go down here. So this is our input down here at the bottom. So I'm going to represent that as the number of miles. Okay, that's my input. And then up along the side, this is the total cost. That's my C value or my Y value, my output. Alright? So, well, we're going to go ahead and just put, this is 0 right here, so we'll put 10, 20, and 30. And we'll count up here by 5s. 5, 10, 15, 20. Okay? Now, the numbers you count by on the side over here, that's called the scale. You can make your scale whatever you want. If you want to count by 2s right here and go 2, 4, 6, 8, 10, 12, all the way up, that's fine. I thought 5s seemed reasonable for this problem. Probably wouldn't want to count by 1s because that's going to be a lot of marks to make and get kind of confusing. Alright, so now I'm just going to make a graph. Well, I know that for 10 miles it costs $12.50, so I'm going to go right about halfway in between here. For 20 miles it was 15, and for 30 miles it was 17.5. Alright, so now when we make our graph, it's going to go like this. Okay? Alright, and we're going to just go ahead and make this run like this and connect it. Okay, it should be a straight line, but it's close enough. Okay, any function we graph for now should make a straight line. Alright, so you just go ahead and connect those. And that's how I want you to graph them. Okay, go ahead and I'm sure you've done graphing before. If you need some help with it, go ahead and ask. And that is, again, our last lesson before the test. So make sure you get your homework taken care of. Ask me any questions on the lessons that you need. And we'll talk more about the test in class. And good luck on it.